Similar triangles use the same principles as similar figures, only we're working with triangles instead. And this is what I had in the last video. You need to make sure that they have the same angles in them. Okay, so those two triangles, if I could write properly, are similar because they have the same angles, alright, and they're a different size. Now, sometimes they try and trick you, and I've seen this in the book, where they have rotated them. Okay, they're still similar because they have the same angles in them. Alright, so that's there. So it's a matter of working out which way they've twisted it and which way to work from it. So all of the theory is the same. You work from the original and try and work out the other one. There are a couple of rules you need to remember. Okay, the scale factor is the same. Is the length of the original? No, wrong way round. Okay, is the length of the image, sorry, divided by the original. Okay, so that hasn't changed. Image divided by original. Alright, but you need to meet, if the triangles are going to be similar, they must meet one of the following conditions. Okay, condition 1. All angles are equal. Okay, now there's a reason I did that in capitals, because this is called the AAA. Okay, all angles are equal. The second is that all sides are same ratio. Okay, now I haven't got a whiz-bang little doohickey for this one, but that's all three sides are the same, basically, or in the same ratio. So if you double one, you double all of them, or something like that. Okay, and the third one is two sides and in between angle so two sides same ratio, sorry, and in between angle is the same. Okay, so I'll draw an example of that. So that's something like where this is 2 and this is 4, and let's say that's 60. Okay, and we draw a bigger one where this is still 60 and that's 8 and that's 4. So you can clearly see that I've doubled the lengths but my angle is the same, and that is called the SAS, side angle side. Okay, so if the side and the angle and the side are the same, or all three sides are the same ratio, or all angles are equal, then the triangles must be similar triangles. Everything else is the same as with similar figures, it's just a matter of finding the appropriate triangle to use. There are some questions, before I move on to the next exercise, where the triangles are within one another. And you'll find this happens quite a bit in what they call real life questions. Okay, so these two triangles, this little triangle here and the whole big triangle, are similar triangles. Alright, so they will ask you to work out some stuff from there. They might give you the height. So let's say this is a tree. I'll even get the green marker out for you. So this is a tree. Okay, and this is a person. You can actually work out the tree, the height of the tree, if you know the height of the person and the angle and the distances there. Okay, so that's the sort of questions you might be coming across in this exercise.